In this OGE, we try to understand how to solve an optimization problem. So when you have optimization problem, there are two options. It can be the maximum or minimum. Normally, actually, it comes from the problem. So let's look at a problem and see, try to understand like how to understand the problem, and then how to set up the problem, and then how to kind of justify that you get the right answer. So let's look at this one. So we have a problem. It says that it is given that the sum of the two numbers is 20. So it says that the sum of two numbers is 20, and it doesn't tell you anything about the numbers. It can be positive, negative, anything. And then the question is asking, find the maximum possible product. So if the sum is 20, a lot of things can happen, but it's asking what is the maximum possible product that you can get if the sum is 20. Um, and then it's also asking, can there be a minimum product for the two numbers? So if you know the two numbers, can there be a minimum product? What's the minimum possible product? Like really interesting problem. So let's try to see like how you kind of do a problem like that. So if you get a problem like that, what we're trying to do first is you try to understand the question. How to understand the question? What we normally do, we pick some numbers that satisfy the conditions, and then we try to kind of see what's really going on. So let's do that. So it says that the sum of the two numbers is 20. So let's say like we can pick numbers like 5 and 15, and then you can see these numbers add up to 20. But what's the product? And you can see that when you multiply the two numbers 5 and 15, you get 75. That's what you get. And then also let's say how about 20 0 and 20, that's also add up to 20. So you can see if you do that, it is 0 times 20 is 0 actually, so it's 0. And then also maybe like you can pick numbers like 13.8 plus 6.2, and then you can see that when you add up those two numbers, it's actually add up to 20. And what do you get if you multiply the two numbers? So you can see if you multiply the two numbers, you actually get 85.56. 85.56. So a lot of different variations, and then sometimes it's gonna go you can see you get a 0, 75, 80, 85.56. So you can see a lot of options, and there are infinitely many choices for those numbers, because because it can be decimal, so that means there are infinitely many choices that gonna add up to 20. So that means it's not like obvious what you're gonna get. And also let's look at few other cases, like for example one of the situation is, can there be two numbers like one is positive and one is negative? Like for example, let's say you get -5 plus 25, and you can see if you add -5 and 25, it's also add up to 20. But what happens when you multiply? When you multiply, you're going to see that -5 times 25, which is actually -125. So you are actually interested in a largest possible product. These this is going to give you a negative answer. So that means that if one is positive and one is negative, you're going to get a negative answer. That means we are not interested in these situations. That means we are not going to pick numbers one is positive and one is negative. What about you pick like two negative numbers? Like for example, let's say you pick -5 and then another negative number. So it is -5 plus, let's say you pick -15, and you can see that there's no way that you can add up to a positive number if both numbers are negative. So it's always like negative. That means this is not also going to give you a because it doesn't satisfy the condition that's given. So that means both numbers can be negative. I mean, but we know that the product is positive, but that doesn't matter because it doesn't satisfy the condition. So that means from this like an analysis, we actually understand that we have some special options. So that's like a good idea to like always do a problem like that. Once you get something like that, see, you try to understand the question and see like what options you have. So you notice that either you know the number should be 0 or positive. So 0 or positive, that's going to give you some viable products, like that can be like, because you got a positive or 0 products. So that means we cannot understand the question now, and then now we can set up the problem. So the next step is setting up the problem. So let's do that. So it'd be better to say set up the equations. So this is how we kind of start a problem like properly. So we're gonna say let x and let x and y be the numbers, with the condition we know that both x and y are positive. So we're gonna pick two positive numbers. Need not to be integers, just two positive numbers. And then we know that we can say then we know that the sum is 20. So sum is 20. So that means x plus y equal 20. So we get that. So that's the first condition. And then for future use, what we try to do is we can actually solve for y. You will see why we want to do that. So we're going to solve for y, which is 20 minus x. So we can use that later. Okay, now what we can do, we can write what they call the objective function. This is the constraint that we have. Constraint is sum is 20. So that's the constraint. It's a constraint. Sum is 20. So we're gonna rewrite this using the variables. It's a constraint. So now let's try the what they call the objective function. So let's have the objective function. So the objective function in this case is the product, because that's what you're trying to maximize or minimize. So that's what we normally call the objective function. So the objective function is a product. So when you say product. So maybe a good letter is P, and you can see that when you write the product, it's a product. So it's a x times y. We normally write x y because in algebra we don't write x times y. When you write x y, it means the product. So that's the product. And then also you notice that this is a two variable function. So we talk about this in the theory. So it's a two variable functions. The problem is when you have multiple variables, more than one variable, we really don't know how to find the optimum value or the maximum or minimum value. You have to bring it down to one variable. So it's okay to start with two variables, but we need to bring it down to one variable. So what we do now, we're going to use a substitution. So you know that y equals, so it's x, but we know that the y equal, we solve for y equal 20 minus x. So we're going to substitute for that. So we did that, and then we're going to simplify this. Once you simplify, what you're going to get is, you're going to see that you're going to get 20x minus x squared when you distribute. So that is the objective function that we get, 20x minus x squared. So we know the function now, and then you can see that it is a one variable function. So you notice that this is a one variable function. Okay, so it's one variable. That's exactly what we need. So we need to make it a one variable function before you find the maximum and minimum value. Now let's try to write the problem. So what we want to do is maximize. You can say maximize p. You can say it's a function of x. So you can say px, which is 20x minus x squared. On what interval? Because you need to write on what interval. If you just write a function like that, it can be confusing. So you can say on what interval, and you can see that according to our understanding, the minimum value that you can have is 0, because if you put a negative value, it's going to be, the product is negative. So we are not going to do that. So the minimum value is 20. So it's on 20. But what is the largest possible value? And you can see that you can have like something like 21. If you have something like 21, to get the sum 20, you need to have a negative number. So that means the largest possible value would be 20. So that means you're going to maximize this function on this interval. So this is the correct objective function on the correct interval. So you have to do that first. Now what we can do, we can use calculus to find the maximum or minimum value from the problem. So let's do that part next. So use a calculus to optimize. But what exactly happened? Like maybe like when you look at the function, like in a general function, you might be having a situation like this. So you can see what happened is, so you get a maximum, what they call a local maximum at a point like that, and then also you get an absolute maximum in a point like that. So what we are interested in is not the local maximum. We are not interested in local maximum. So we are interested in the absolute maximum. What is the absolute value of the function? So let's exactly see what happened. So what we normally do, if you want to use a calculus, what we're trying to do is we're going to find the critical points. find a critical point. So let's go ahead and find the critical point. So we have our function p, x is a function of x now. So it is 20x minus x squared. So let's go ahead and find the derivative. Is a p prime x. You can see it is 20 minus 2x. Now what we do is, you do not get 0. What we do, we set this equal to 0. This is very important because you know that we are looking for where the derivative is 0. So you set this equal to 0, and then you know like what happened here. So this is very easy to solve for x. So it is you can see 20 equal 2x. So if you divide by 2, so you get 10 equal x, or x equal 10. So that means you notice that the critical points are, we normally call c dot p dot, critical points are x equal 10. And you notice that there is only one critical point. This is a very interesting part, only one. Okay, so there's a one critical point. So one critical point means you cannot have a situation like this. So you can see in the graph, you see like another critical point here. So that means since this is a one critical point, you cannot have a situation like that. You cannot have a turn and get a like a larger absolute. That means this point should be the absolute maximum. Whatever that point x equal 10, so that means there should be the absolute maximum at x equal 10. X equal 10 is not the absolute maximum. There's an absolute maximum at x equal 10. But what we normally do in calculus, we can use like three different tests. So one test is we can use the absolute maximum test. What's the absolute maximum test? We're going to find the value at the critical points. We're going to find the value at the endpoints and pick the largest value or the minimum value depending on the situation as the absolute value, absolute maximum minimum value. And there are other tests like also the first derivative test, what we normally call FDT, to find the absolute maximum minimum or like local maximum minimum. And also we also use the second derivative test to find the local maximum minimum. So in this case, like the typical method would be like if you get like an easy equation, what we normally use, we use a second derivative test because that's very easy to do. So this is what we normally call the justify the answer. So let's do that now. For that, what we do, we're going to look at the second derivative. So this is like a most common one when you especially figure easy one. So when you look at second derivative, you can see that it is negative 2, and then which is negative. Very interesting. That means even, because this is for any x, even at the critical point, you have to look at what happened at the critical point. What happens? So x equal, you plug in 10 is also negative 2 because it's a negative number. This says that by the second derivative test, this says that there is a maximum. So has a maximum, okay, as a maximum. So that means we justify that by the second derivative test, there's a maximum value at that point. But you have to do that because in general, if you just find the critical point and say that's the maximum, that's wrong argument, because you know that we really don't know. Even in this graph, you really don't know whether the critical point has a maximum or minimum. It can be both. So that means you need to write this step just to like if you do a problem in an exam, you make sure you write this one, otherwise you can lose points because you did not justify the answer, because it's not obvious that there's a maximum. Now because of this one, there's a maximum. So now what we can do, so you can say so we're gonna complete the problem like this. So we can say there's a maximum at x equal 10. So we're gonna say there is a maximum at x equal. So then what we do is, so we know that there's a maximum at x equal 10. But what we need to find the actual maximum product, we also need to find the corresponding y value. So that's the next step. After you find what is the critical point which has the maximum, we're going to find the corresponding values of the other variables, in this case y. So let's do that now. So we can see at x equal 10, and you know that y equal 20 minus x, that's from the formula. So let's plug in. So it is 20 minus 10 in this case, that means which is 10. So that means that's the corresponding y value for x equal 10. That's the corresponding value. Now we can write the maximum product. So then the maximum product, is, you can say p equal 10 times 10, which is 100. So 100 is the maximum possible value that you can get for this, okay, because you're asking the maximum product, you have to find the maximum product. And also So this is how you like completely complete the problem. So there are also other options, like for example, you can use the I'm just like mention those things, like in different problems we might do those other things. So we have like another method. Uh, so method 2, the absolute extrema test, absolute extrema test. And also you can do another method. So method 3 would be, you can say the first derivative test. You can use the first derivative test. That's the method 3. There's another method 4. For a problem like that, actually you can see that your problem px, what you get is 20x minus x squared, which is a upside down parabola. You see that? So you can see it, which is upside down parabola, upside down parabola, or concave down parabola. So that means if you look at the graph of something like that, you can see there are two zeros. Uh, Actually, yeah, there are two zeros. One at 0 and one at 20. So that means it's going to go like that. It's upside down parabola. It's going to go like that. So that's the shape of the graph. And there are two zeros, one at 0 and one at 20. So you can see that since the parabola, there's a symmetry. So the maximum should happen at the center point, which is 10. You add the two numbers and divide by 2. So this is like another way. So if you have a parabola, you can see the maximum should happen at the center point. So that's like another argument. That's the absolute maximum. So we have actually 4 different techniques to kind of justify that you get a maximum value, but we can do other techniques in other problems. So you can see like so we try to use different techniques in different problems just to like learn how we can use them. But most common way to use is the second derivative test. So let's see in other problems what we're gonna do. And also you can look at the major video about optimization problems. So we're gonna do about 10-15 problems there, and you can find the link in the description for all of them. And also like before you do more problems, I ask you to watch the video about how to solve any optimization problem, like there's just a basic theory video. It's not that long. It's like about 16 minutes, and you can find the link in the description. Okay, so thank you so much for watching.